Okay, ladies and gentlemen, let's get into this here real quick. What I want to show you in this video is how to work with something called exponential functions. Okay, so the problem that I want to work with to start is 8 number 8 from this little example, and what we're trying to find is x. So we want to find x. Okay, so the example that I'm going to work is 8 plus 5 raised to the power of 2x plus 3. And I'm going to set that equal to 12. Okay, so this is the given information. This is called an exponential equation because there's an x up here in the exponent of that 5. All right, so here's how we solve equations like this, because you have up until now really not worked with this type of information if you've been in my classes. So let me show you what to do. First, we just start by isolating that term that has the exponent by subtracting 8 from both sides. No new information there. Okay, so 8 minus 8 is 0 on the left and 4 on the right. On the left side, we have 5 raised to the power of 2x plus 3, and that is equal to 4. Now, in order to move forward, we have to do something called taking the natural logarithm, and that's abbreviated by the term ln. So I'm going to use a different colored pen to write that this first time. We have to take the natural logarithm, okay, ln, of 5 raised to the power of 2x plus 3, and we have to take the natural log of 4, okay? Right now, we're just going to leave it like that. What happens when you do this is you're able to bring down this 2x plus 3 like this. So you're able to bring down the 2x plus 3, and all that's left is the natural log of 5. Okay, so ln of 5. And this is multiplied here, okay? And that's set equal to ln of 4. Now, you're going to work with these terms here as if they were variables, okay? So for right now, we're not going to evaluate them. We're just going to isolate them. So what I mean by that is we'll divide both sides by ln of 5. Okay, they cancel out on the left, and now you're kind of getting closer to getting x by itself. We have 2x plus 3 equals the natural log of 4, which we haven't evaluated yet, over the natural log of 5. Okay, so we just continue working with this problem. Let's subtract 3 from both sides. On the left, those 3's go to 0. And now we have 2x equals the natural log of 4 over the natural log of 5 minus 3. Okay, so your intuition about what to do next, if you're not thinking too deeply about what is going on over here, is to just divide by 2. And that's exactly what you're going to do. You're going to divide by 2 on the left, and we'll do the equivalent of dividing by 2 on the right by multiplying the entire right side of the equation by 1/2. It's just dividing by 2. Okay, so now we have x by itself, and so x equals all of this, but we're going to simplify what we see here. Okay, so one thing I'm going to do is distribute that 1/2 through both terms in the parentheses, so I have ln of 4 over 2 times ln of 5 minus 3 over 2. All right, so we could stop here, or we could get a common denominator and just write this a little bit more cleanly. And this is more of a style thing. So we can say x equals ln of 4 minus 3 times ln of 5 all over 2 times ln of 5. All right, and that's it. So that's all you can do by hand. And what you have to do now is you have to go to a calculator to find the answer. So if I hit alpha y equals enter, I get this nice little fraction entry system. And this key right here, which we've never hit before, is the natural logarithm key. So what you're going to type in here is just everything you see right here, right? In the numerator, we'll hit ln 4 minus 3 ln 5 all over 2 ln 5. Okay, and we hit enter, and it approximates the natural logarithms and does all of the operations here in this fraction to give us an approximate answer. Okay, it's just an approximation. X is equal approximately, okay, that's a squiggly line, to negative 1.069323442. Okay. If you wanted to kind of prove that this was right, we could take this whole thing right here and stick it back into our original equation. So I'm going to put in negative 1.069323442 in for that x and just solve this out. And what I'll do is I'll solve it from this state here where I had 5 raised to the power of 2x plus 3 equals 4. And let me show you what I'm going to do here. So if I go in here and I write my original equation, 8 plus 5 raised to the power of 2. Oh, you can't see it. Sorry. Go up here. 8 plus 5 raised to the power 2, and then open parentheses, and we're just going to stick the x in there, right, which is negative 1.069323442, and again, it's just an approximation. And then what happens next? We do plus 3 after that, okay? So let's go up here and do plus 3. And that is all supposed to equal 12. All right, so the question is, does it? Well, we go to our calculator, we can type 8 plus 5 raised to the power of 2, open parentheses, and I can grab all of that, close parentheses, plus 3, and we see that it equals 12, okay? So that's how natural logarithms work, and I wanted to jump in with a kind of a good meaty example so you could see how this is going to end up working in terms of algebra and algebra 2. So I hope this was helpful. I'll do another example in another video, but I wanted to give you a taste of what natural logarithms are and a taste of how to solve for x when you're dealing with an exponential equation. So I hope this was beneficial to you. Thanks.